Good everyone, my name is Graphics. If you look at the front of your screen, you see a question, and the question says water is flowing through a pipe having diameters 20 centimeter and 10 centimeter at section 1 and 2 respectively. The rate of flow through the pipe is 35 liters per second. The section 1 is 6 meter above datum and section 2 is 4 meter above datum. If the pressure at section 1 is 39.24 Newton per centimeter square, determine the intensity of pressure at section 2. Now, the first thing you do in this question is for you to write out the data given, and this will give you a direction to follow. So let's start writing out the data. Now, it says the diameters here is 20 centimeter and 10 centimeter at section 1 and section 2 respectively, meaning that diameter at section 1 is 20 centimeter and diameter at section 2 is what? Is 10 centimeter. So I'll use d sub 1 as diameter for section 1 and I'll be using d sub 2 at diameter of section 2. In fact, anytime you see d sub 1, anytime you see sub 1, it means section 1. And whenever you see sub 2, it means what? Section 2. So my D1 here is 20 centimeter. And when I convert centimeter to SI units, that is standard unit system, taking it to meter, meaning that I'll divide through by what? By 100, because the word cent means 1 over 100. So 1 over 100 times 20 will give you 20 over 100. And 20 over 100 means what? 0.2 meter, right? Now, I will now advise, whenever you calculate for diameter, try and calculate for what? Also the area, to make your work easier in the later stage of the calculation. So, meaning that the area at that particular section, A sub 1, will be equals to pi D1 square all over what? All over 4. So, from now, we will now say the pi is 22 over 7, which will give us 3.142, multiplied by the d sub 1, which is the diameter at section 1, which is 0.2 square all over 4. So by the time you do your calculation, 3.142 times 0.2 square will give us 0.1257 divided by what? 4. And this will give us 0.03143 meter square. So that is the area for section 1. Now, for this sub 2, we're told it is what? 10 centimeter, right? So converting it to meter means you're dividing by 100. So we're having 0.1 meter. Now, calculating for the area at section 2, which is A sub 2, will be giving us pi d2 square over 4, which means 22 over 7, that is 3.142 times the d2 is 0.1. We have square there divided by 4. Now, if you multiply 3.142 times 0.1 square, you'll be having 0.03142 all divided by 4. And that's going to give us 0.00786 meter square, right? That is the A sub 2, the area at section 2. Now we'll read further. In that say the rate of flow through the pipe is 35 liters per second. So that is the discharge. We use the symbol Q to represent our discharge. So the discharge will now give me 35 liter per second. Now I want to convert liter to a SI unit, right? That is a standard unit system here, which will be in meter cube. To convert from liter to what? To meter cube. So that means we'll be multiplying by 10 raised power what? Minus 3 meter cube. So meaning 1 liter is equals to what? 10 raised power minus 3 meter cube. Or we say 1 all over 10 raised power 3 meter cube. That is 1 liter. So by that way, you say 35 times 1 over 10 raised power 3, meaning 35 divided by what? 1000, because 10 raised power 3 is 1000. So 35 over 1000, so we're having 0.035 meter cube per second. Are we together? Now we'll move further. Then it says that what? That the section 1 is 6 meter above the datum and section 2 is 4 meter above the datum. When we talk about datum means elevation from the reference line. So their section 1 we use that is the potential energy here, or is it the potential head? Z1 here is given as what? 6 meter, and Z2 here is given as what? 4 meter. Now we'll move further. It says if the pressure at section 1 is 39.24 Newton per centimeter square. So the pressure at section 1 is given as what? 39.24 Newton per centimeter square. And I want uniformity. I want all my units here to be in meters. So I'm going to transform this centimeter square into meter square. So what will I do? When you say 39.24 Newton per centimeter square, since you are saying 39.24 Newton all over what? Centimeter square, right? And we know cent means 10 raised power minus 2, and it has square. So it means 39.24 Newton all over what? 10 raised power minus 2 all square, then meter square. And which is the same to you multiply your indices. Minus 2 times 2 give you what? Minus 4. So we're having 39.24 all over what? 10 raised power what? Minus 4 meter square, right? And you know when the 10 raised power minus 4 is coming up, it will become what? Positive. So we have 10 raised power 4. And 10 raised power 4 means what? 10,000. So we have 39.24 Newton, 39.24 times 10,000. And that will give us what? 392,400, right? Newton per what? Meter square. Are we together? So diagrammatically, what this is telling us is this. This is what we have here, right? This is my section 1 and section 2. This is my streamline, the center line here, that's my streamline. From the center line to the reference point here, the height is what? The datum is what? 6 meter. So it's higher. While the section 2 is lower to the reference line, which is 4 meter. Are we together now? So section 1, the pipe is wider, that is why it's 20 centimeter, which is equivalent to what? 0.2 meter. And at the section 2, the diameter is smaller, which is 10 centimeter, which is equivalent to what? 0.1 meter. Is that okay now? So as we are solving, you see that our velocity here at section 2 will be higher, and velocity at section 1 will be what? Lower. Why? Because this is a nozzle. In a nozzle where the outlet is higher, where the outlet is the diameter of the outlet is smaller than the inlet, the velocity is always very high. So this is what we just have here. So at this section 1, we have pressure P1, V1, discharge is the same at the inlet and also what? At the outlet also. Is that taken? So this is our diagrammatical representation. So let's move forward and let's see how it goes. So viewers, you're finding this video helpful, please don't forget to like the video, subscribe to the channel, and also share the video if possible. So let's proceed. So we'll move further. Now we're now told to determine the intensity of pressure at section 2. So we're looking for what? P sub 2. That's what we're looking for. Now there's some things you need to know. We're talking about water, and density of water is given as 1000 kilogram per meter cube, and the weight of water is 9.81 kilonewton per meter square, right? That is the gravity of water there. So we'll move forward. Now, since we'll be applying Bernoulli equation to this problem here. So since we have two sections, what is Bernoulli equation here? Before I write out the formula, you need to understand what Bernoulli equation states. What Bernoulli states. It says that in an ideal incompressible fluid, when the flow is steady and continuous, the sum of the pressure energy, kinetic energy, and potential energy, which is the datum here, right, are constant along the streamline. So in this case, what we'll do is, what it means is that what? My pressure head or pressure energy, which is P all over what? Pressure all over what? Specific weight, plus the velocity square all over what? 2 times gravity, plus the datum, which is Z, equals to what? C. They are all constant. That was telling us the pressure, energy, kinetic energy, and potential energy are all constant. Right? This is the law, what the law is telling us. But now we want to apply it to both ends. Since the pipe we're talking about, water is flowing, it has an inlet and an outlet. It has section 1 and section 2. So we'll put it in two places. So we'll be writing P sub 1 over what? Specific weight plus the velocity sub 1 square all over what? 2 times the gravity plus Z sub 1 equals to, at section 2, we have P sub 2 all over specific weight plus the velocity sub 2 square all over 2 times gravity plus what? Plus Z sub 2. So this is what we're having. This is what we are going to be applying. So I'm going to term this my equation 1. Are we there? So now, before I move further, we need to understand that my specific weight is giving us density times what? Times gravity. And we know the density is 1000 and gravity is 9.81. So we multiply both of them, you'll be having 9,810 Newton per what? Per meter square. Newton per meter cube. That's what you'll be having here. So we'll move further. So if I should now input it here to represent my specific weight, so I'll be writing it to be, I will now change this my specific weight to be 9,810. So calculating for velocity at section 1 and section 2. So I'll be putting V sub 1 and V sub 2. Now you need to have one thing in mind, that the discharge at section 1 is equal to what? The discharge at section 2, which is equal to what? From what we have here, that is 0.035 meter cube per seconds. Right? Have that in mind. So we'll move further. So recall, at section 1, right, we say that the discharge at section 1 is equal to what? The area at section 1 times the velocity at section 1. Remember that formula. Discharge is equal to what? Area times velocity. So when you're using at section 1, you use sub 1 there. So we'll move further. Now we'll now say that when you put your value for discharge, we have, remember, discharge at section 1 is equal to discharge at section 2, and is equal to what? What we have here, 0.035 meter cube per second. So inputting into this formula, we say that 0.035 is equals to the area at section 1, which is given as what? 0.03143 meter square, right? So that is what we have. So by the time you now times the velocity at section 1, so by the time you now make the velocity at section 1 sort of formula, we'll now say that my 0.035 divided by 0.03143 is equals to V1. So V1 will now give us 1.114 meter per second. So that is the velocity at section 1. So at section 2, we say the same formula, Q sub 2 is equals to A sub 2 times V sub 2. We know the Q2 is equals to the what? The Q1, and that is 0.035 equals to area at section 2 is 0.00786 times V2. So when you make V2 sort of formula, meaning you are dividing both sides by what is close to V2, and you'll be having 0.035 divided by 0.00786. So my V sub 2 will now give us 4.453 meter per seconds. We've gotten V1 and V2. Now you now put all the parameters that will fit into equation 1. And what is equation 1? This is our equation 1 here, right? It says that my P sub 1 is equals to 9,810 plus V sub 1 square all over 2G plus Z1 equals to P2 over 9,810 plus V2 square over 2G plus Z2. That's my equation 1. So let's start putting our value. We have for the P sub 1, it is 392,400 divided by 9,810 plus V1 is giving us 1.114, there is a square there, divided by 2 times G is 9.81, otherwise stated, plus Z1 is 6, equals to P2, that's what we're looking for, all over 9,810 plus V2 is given as 4.453, there's a square there, divided by 2 times 9.81 plus 4. Now, what I will do is, if you now divide 39, we now divide 392,400 over 9,810, you'll be having 40, right? Plus, if you divide 1.114 square is 1.241, right? All over 19.62. When you divide both of them, you're going to be having 0.0633 plus 6 equals to, close to P2, we have 1. So 1 divided by 9,810 will give us 0.000102 P2. When you place 4.453 square, you'll be having 19.83 divided by 19.62. When you multiply 2 times 9.81, and that will give us what? 1.0107 plus 4. Now, if you collect like terms, 40 plus 0.0633 plus 6 will give us 46.063 equals to 0.000102 P2 plus 1.0107 plus 4 will give us 5.0107, right? So this is what we have here. So from here, you now collect like terms. You will make P2 the subject of the formula. So we're having 46.063 minus, if you take 5.0107 to the left hand side, it will become minus. So we have minus 5.0107. And when you are subtracting, you have 41.053 equals to 0.000102 P2. So if you make P2 the solid of the formula, P2 will be equals to what? 41.053 divided by 0.000102. And if you divide it, you have 402,480.39 Newton per meter square. And converting it back to centimeter, you divide by what? By 10,000. And that will be what? 40.24 Newton per centimeter square. So it means that the pressure intensity at section 2 is 40.24 Newton per centimeter square, right? Or 402,480.39 Newton per meter square, any of the two. Then at section 1, we already know what it is. So this is what we have there. So if you have found the video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.